What's up, everyone, and welcome back to DevOps Corner. Today, we are diving deep into a core Kubernetes concept you absolutely need to know. Hey, if this explainer helps you out, do me a favor and hit that like and subscribe button. That way you won't miss out on any of our future content.
All right, let's get right into it. Today's topic is all about Kubernetes configuration, specifically how we handle it using two key players, ConfigMaps and Secrets.
So you've built your application, you've containerized it, and you're ready to deploy. But then you hit that classic wall, right? How in the world do you get your configuration files, your API endpoints, and especially your sensitive data like passwords, into your app when it's running inside a Kubernetes pod?
Now, if you're coming from a world with a single Docker host, life was pretty simple. You just mount a file from the host, and you were done. But Kubernetes? Well, it's a whole different ballgame. We're talking about a distributed cluster where your pods are ephemeral. They can pop into existence on one node and be destroyed and recreated on another moments later. You can't rely on local files anymore. You need a central, reliable place to store that configuration.
And this is where Kubernetes really steps up to the plate. It gives us two native objects, built right into the system to solve this exact problem, ConfigMaps and Secrets. These are your go-to tools for separating your configuration from your application code.
Let's kick things off with our first hero of the day. For all of your general, everyday, non-sensitive configuration, the tool you're going to reach for is the ConfigMap.
So what is a ConfigMap really? Well, at its heart, it's basically a dictionary. It's a Kubernetes object that lets you store your non-confidential data as simple key-value pairs. This is awesome because it completely decouples your config from your container image.
And this is where they get really flexible. You can use them to store individual little settings, like a URL or a feature flag, which are perfect for injecting as environment variables. Or, and this is incredibly powerful, you can take an entire configuration file, like your whole nginx.conf, and store it as the value for a single key.
Let's look at how this works in the real world. Here's a YAML file for an nginx config map. You can see the kind is ConfigMap, and we've named it. But the real magic is here, in the data field. The key is what we'll call our file, nginx.conf, and the value, everything after that pipe symbol, is the literal multi-line content of that config file.
Okay, great. So we have this config map sitting in our cluster. How do we get it into our nginx pod? Well, it's pretty much a three-step dance. First, you create the config map resource itself. Second, inside your pod's YAML, you define a volume and tell it to use the config map you just made. And finally, you use a volume mount to project that volume as a file right into your container, at the exact path you need, overriding the default config.
This is all well and good for regular config, but it brings up a huge question. What about the stuff you can't just leave lying around in plain text? I'm talking about API keys, database passwords, TLS certificates, the sensitive stuff.
And for that, we need to talk about the ConfigMap's more security-conscious sibling, the Kubernetes Secret. This is the tool designed specifically for handling your confidential data.
Now, a secret is functionally very similar to a config map. It's still a key value store. The big, crucial difference is its intent. It is designed from the ground up to hold sensitive data, and to provide a basic layer of obfuscation just to keep it from being human-readable at a glance. Kubernetes stores the values inside a secret as base 64 encoded string.
Now, I'm going to let you in on a pro tip that's going to make your life way easier. When you create a secret, you can use two different fields, data or string data. If you use the data field, you have to manually base 64 encode your values before you put them in the YAML. It's a pain. But if you use string data, you can just paste the raw plain text value and Kubernetes does all the encoding work for you. Trust me, you'll want to use string data.
Check this out. Here we're creating a secret for a MySQL database password. We've set the kind to secret, and look, we're using that awesome string data field. We just define our key, root pass, and put the plain text password right there. When we apply this, Kubernetes will handle the encoding behind the scenes. So much cleaner.
So, how does our app actually get this password? A super common way is to inject it as an environment variable. Inside your pod's container spec, you define an environment variable, say MySQL root password. But instead of giving it a hard-coded value, you use value from. This tells Kubernetes, hey, the value for this variable isn't here. Go look in the MySQL secret object and pull out the data associated with the root pass key.
All right, we've met the two contenders. Now let's put them in the ring, side by side, to make it absolutely crystal clear when to use one versus the other.
It really all boils down to one simple question. Is the data sensitive? If the answer is no, use a ConfigMap. This is for your plain text, general config, things like feature flags or Nginx configurations. If the answer is yes, you use a secret. This is for anything you wouldn't want to check into source control, passwords, API tokens, certificates. The key difference in format is that secrets are base64 encoded.
Okay, before we finish up, I really need you to lean in for this part. This is probably the single most important takeaway of this entire explainer, and it's all about the security of Kubernetes secrets.
I want you to burn this sentence into your brain. I'm going to say it loud and clear. Base64 encoding is not encryption. It's just a way to represent binary data as text. It offers zero actual security.
So what does this actually mean for you? It means that anyone with permission to read secret objects in your Kubernetes cluster can retrieve the encoded value and decode it trivially. It's a one-line command. And by default, Kubernetes stores these secrets unencrypted in its central database etcd. This is why role-based access control, or RBAC, is your absolute first and most important line of defense. You must lock down who and what can read secrets.
So this naturally leads to a really important follow-up question. If a standard Kubernetes secret is just a thin veil of obfuscation, what's the next step? How do you achieve true end-to-end security for your credentials in a production cluster? Well, that's a whole other topic for a future explainer, but it involves amazing tools like external secret managers and integrations with systems like HashiCorp Vault.
And that's our look at ConfigMaps and Secrets. I really hope this helped clear up how you can manage configuration cleanly and effectively in Kubernetes. If you found it useful, please hit that like button and share it with your team. Thanks so much for tuning in, and I'll catch you in the next one.